Tail to what I was talking about this morning. A little bit more of a flavor towards a couple of different crops that I understand you grow. And if there's any questions, remember, by all means, speak up, get my attention, put your hand up. Let's ask the questions as we go. I do this more for me than you. You know how often I pick up the phone and say, "Hi, Rick, from AgroK speaking." After 10 years, it's hard to break the habit. But now I get, "Hi, Rick, from Ravenda." Anyways, let's get into the talk. Just as a very, very brief recap, because I don't want to run out of time, like I did this morning. And I got a lot of other data beyond another conversation beyond what we talked about this morning. But just as a recap, remember the five R's, fundamental principles to crop nutrition: right nutrient, right time, right place, right mix, right form. And I did that without looking at the slide. The better we can apply these, the better the outcomes. Quite literally, right? This is what we see, and I see this time and time again. This is what drives my why when I see healthier crops. Geez, that field just looks healthier. Well, if I have a healthier field and I get that insect or disease pressure, if the plants are already healthier, do you think that pesticide might work a little bit better? Right? If the crop isn't quite so dire, absolutely. Do you think you might use a few less pesticides? Maybe, right? So healthier plants. I love it when we get healthier plants. Yeah, that's usually one of the first comments I get off a grower. Geez, the field just looks better. It just looks healthier. I'm actually going through less pesticide. I love it. Higher yields. That's good on your end. You're getting more crop and you're getting better quality. And that depends on how you want, and that regardless of how you want to define it. Is that better quality? Higher yield. Firmer fruit, better shelf life. Potatoes, less hollow heart. I don't know, it could be any number how you define it, but we always see better quality. And the big winner for me is the fertilizer efficiency, right? We're not wasting our dollars on fertilizer anymore. To me, that's a big one. I see a lot of it, and I want to see it stop. I want to see it more targeted. And I call all of this, as much as they're fundamental principles, I want to be responsible with my crop nutrition. So how can we do this? What are some of the tools that we have in our tool belt? Well, we use science. We talked this morning about doing soil sampling. Pretty important. And we want that soil sample to be, 2, 3, 4, maybe 5 years on the outside, not 10 or 20 years old. 20-year-old soil sample isn't going to tell a lot about what's going on in the field today. It's going to tell you what happened 20 years ago. Crop sampling. Not every crop can be sampled. Apples, if you're doing any apples, boy, we have lots of data on fruit analysis of apples come at harvest. We can do lots of predicting to how that apple's going to store, whether it's going to have bitter pit or other calcium disease issues or whatnot. We have a lot, so it's not always applicable, but where it is, we want to do some crop sampling coming into harvest. Tissue sampling. I've left it up there. I'm not a big fan of tissue sampling anymore. I used to do a lot of tissue sampling, but in the last 10 years, I've discovered a different tool, and I kind of like it, and it's called sap analysis. And that's what I want to speak to you now. Look at this, I got caught on the slide. I shoved a soil slide in there. So think sap analysis and put that on pause for a quick second. Soil testing every 3 to 5 years. Keep in mind your soil pH is critical. Now, some agronomists might tell you, let's work on that soil pH. And you know what? If your soil pH is relatively acidic and you're trying to bring it up to make nutrients a little bit more available, I get that. That's usually pretty easy to do. We can put on some lime or some dolomite and bring those soil pHs up. But bringing soil pH down, we typically use something called elemental sulfur. And guess what? It's expensive. And if you have some decent organic matter in your soils, and I come from the Okanagan, so if you got anything over 1.5 or 2% organic matter, that soil pH is going to have a fairly strong buffer to it. It's not going to move very easily. Sulfur is quite expensive. You know what? My advice to you, live with it. Don't spend the money to try to bring down that pH. Your higher pH soil, 7.3, 7.5, 7.8, those soil pHs are going to be really hard to change. Work with them. The good news in those pH soils if I'm growing a berry crop, like a Haskap or a Saskatoon perhaps, or a cherry, guess what? One of the key nutrients you need to grow a nice firm berry that actually is going to last for a little bit is calcium. Calcium is the most available above pH 7, 7.3, 7.5. Calcium availability is ideal. So is magnesium, also another one that these type of crops need. So you know what? On apple crops now, we're no longer talking about that ideal pH is 6.5. We used to say all the time, the ideal pH 6.5. Why? Because that kind of optimizes availability of all the nutrients as best as possible. It's the sweet spot. Problem is, not all the nutrients are the same for the crop that we're talking about. I'd rather optimize the nutrients that the crop needs the most and also cost the most. I'd rather augment the ones that are cheaper and maybe not as in demand. I can fix those with a spray or through the fertigation or whatever way easier than changing the pH. So for most of our crops, if your pH is 7.3, 7.5, and you've got higher pH soils with calcium in it, guess what? That's making the calcium available. The crop is going to be able to tap into that. Say, whoopee, and run with it. Now, on the other end, a nutrient like iron that doesn't like that high pH, you're probably going to need to put on a few iron sprays. That's a whole lot cheaper than changing the pH, because it's going to go back up again. That's going to be an ongoing battle, and elemental sulfur regularly is expensive. You bet.
And you'll find, if you do a soil test on a high pH soil,
yep,
your iron levels are going to come up as sufficient.
Yeah.
But you see a deficiency.
Absolutely. And we see that. That's exactly it. Just because it's in the ground doesn't mean it's in the soil. And I see that very regularly. I'll see 200 or 250 ppm of iron in a soil sample, which is tons. And at pH 7.5, most of it's not coming in.
I learned that from Dell.
And he was right. Absolutely. I'm going to share with you what I call the Dell 150 rule in a little bit, in honor of Dell. Very close mentor of mine. This used to be the chart, particularly when looking at soil, but when looking at nutrients in general, we used to have this barrel, and we always said, let's identify the lowest plank on the barrel. We fixed that, and everything's going to be fine. So the lowest plank here is calcium. So all we got to do is add more calcium, right? Right? Just add more calcium. That's the lowest plank. That's the limiting factor. Well, the problem is that calcium is going to push those other ones down. And what really is happening here is you got all of these cations. Cations, remember, positive charge, nutrients in larger quantities. Guess what? They're competing with each other. So note those planks are really high. So let's drop down the key planks. So the answer here, what we've discovered, isn't so much that we needed to add calcium. Maybe if we add less potassium and magnesium, the calcium will come up on its own. And lo and behold, more often than not, that's exactly what happens. So less fertilizer, more precise fertilizer, and watching out the right nutrient at the right time, right mix, all those antagonisms and synergies, what we've discovered is exactly this. We put on less K, calcium goes up. So rather than putting on more nutrient, sometimes the answer is putting on less. This is what I work with now. Now, if you want to guaranteed put you to sleep at night, you can Google the Mulder's chart. Guaranteed to put you to sleep. I mean, I'm a nutrient geek, and this puts me to sleep when I really dive into it. But it's a good way of looking at all the different nutrient interactions and synergies and antagonisms that are taking place. This is what makes, by the way, fertilizer research really hard to do. I looked at research once. I remember going to, it was the Wild Blueberry Association's International Research Day, and it was somewhere in New Brunswick that year. And there were researchers stood up from Quebec and did a whole presentation on his research on calcium. And what he discovered, how it came with water stuff, which to me is like, yeah, it moves with water. Yeah, okay, no. But anyways, all he did was talk about calcium. Well, one of the major interactions that I shared with you this morning is potassium, right? So I just asked him, you know, in these research plots, did you ever do some analytical work to determine the nutrient levels of the other cations, and very specifically potassium? No. So he did all this research and never took into account how potassium would antagonize calcium. As far as I'm concerned, it wasn't worth the paper it was written on, because you didn't look at the full picture. But this is the full picture. This is where I get to spend my day, my days, and sometimes in my dreams, but that's another story. We need a tool. We need a tool to work with that can really show this. And this is the tool that I got familiar with, and now I use a fair bit. This is the tool that I'm using instead of tissue sampling. And it's called sap analysis. Sounds kind of techy, I hope. Anyways, it's a pretty neat tool. It's a pretty unique tool. There we go. I often hear it referred to as a blood sample for plants. So what we're doing is we're sending the samples to a lab of just the leaves, no petioles. We don't want the stems. They actually pollute the samples. Because what is the stem? What does the stem do? It's a conduit. It's a highway between the plant and the leaf. The leaf is what we call a sink. It stores nutrients. It moves, but it stores. That highway is polluting it. I don't want to know what's moving down the highway. I want to know what's in the sink. So the stem actually pollutes it. And here's an interesting little fact. And talking to Andy earlier why I'm very concerned about petiole sampling. Petiole sampling is very common in potatoes, right? Grapes as well. They rely heavily on potatoes. And I wasn't planning to say this today, but I'll say it with pride. Petiole sampling is flawed. Doesn't work. How's that for a big one for you? The reason for it is sap analysis has showed us that those petioles, that highway between the leaf and the rest of the plant, certain nutrients only travel that highway at certain times of the day. Boron, prime example. And remember what happens when boron gets toxic, right? Cell mortality, that frying the cells kind of idea, killing the plant kind of idea. Well, guess what? Boron is only traveling that petiole early in the morning and later in the afternoon. So if I'm getting up early and doing my sample, I could get a false high. And if I'm getting up kind of late, because I had a few phone calls to make, and I get out in the mid-afternoon or late morning, I'm getting a false low. It's hard to get an accurate reading on boron using a petiole sample. And yet, it's one of the most critical nutrients we need to know what's going on to build a nutritional program, because the ramifications of getting it wrong is cell mortality and plant death, quite literally. So, sap analysis without the petioles. Here's the lab that I'm working with. And for the record, I get no money from them whatsoever. I'm not connected with them financially in any way, shape, or form. The individual that introduced me to this company way back 10 years ago was Del Christensen. Back then, he was just trying to figure this out as far as how to read these samples, because they are uniquely different to read. You go, okay, we're looking at a sample. We put less K on and the calcium went up. Well, this must be wrong because I didn't put on more calcium. I put on less K. Well, hang on here. We talk about these interactions. Now we can actually see them. It blew our minds away that we actually have a test now that's so fine-tuned we can actually see these nutrient interactions as they're happening through the growing season, instead of just talking about them. And trust me, I'm in sales, right? This lab has been doing this since 2003 commercially. They figured it out. They are the market leader, which is why I'm using them. There are labs in North America that are starting to figure it out. Perhaps we'll get there here in North America, or even better, maybe these guys will open up a lab in North America. I've been talking to them and kind of encouraging them on that, because that makes it a lot easier. But they have optimum ranges for over 200 different crops. Turnaround time is about 7 days, 5 to 7 days. We pull samples Wednesday, Thursday, let them sit overnight in the fridge so that they cool down. We ship them over to the Netherlands on Friday with express courier. We get the results on Tuesday. So within a week, we're getting results. Average cost about $120 to $130. And for that, we're getting analyzed at double set, because we were doing young leaf and old leaf separately. And I'll talk about the why behind that in a minute. So it's not an overly crazily expensive for what you get. It is quite different than a tissue sample. I like to now refer to a tissue sample as looking backwards. And the reason I say that is, what is a tissue sample? They're taking the entire leaf, including the stem. They're drying it down, grinding it up, and analyzing it. So if I have nutrient that's on that leaf, because I just did a nutrient spray, but I used one of those EDTA chelates that I was talking about this morning, that coat the leaf but don't get in the leaf, guess what? It's going to show up in the tissue. Because that tissue sample, a large component of it, 80% of it thereabouts, is leaf dry matter. And that leaf dry matter has nutrient on it and in it that's captured, but it's not available to support the growth of the crop. It's in the leaf dry matter. It's viewing the results. It's not telling me what's happening today. It's telling me what's happened in the past. It typically has about 12 to 13 different data points. When we pull those samples, we tend to pull them from the middle of the new growth of the crop. Well, nutrients move differently in the plant. See, we have nutrients like boron that don't move well in the plant. So we need to look at that young leaf to look at what the borons do. Fully expanded, but young leaf. Well, we have other nutrients like phosphorus, nitrogen, and potassium that move very well in the plant, which means they get stored in that sink of the lower leaves. Well, we need to look at that lower leaf to see what we got for reserves. Maybe the K in the young growth is starting to run a bit lean, but if there's lots of K down below in the old leaf, it'll pull it up as it needs it. I don't need to apply anymore. The plant's got it covered. Where opposite, say my young growth is doing good on K, but I got nothing in the old growth. And I'm coming into a period where I'm pushing fruit color. I'm trying to get those berries to go blue. Guess what? I'm going to run out of K. I've just predicted a potassium deficiency before it's actually happened in the plant. This is allowing us to see that now. Here are the optimum ranges that I think are pertinent for today's conversation. No, they do not have Saskatoons yet. But how many labs can tell you they've got optimum nutrient ranges for a nutrient analysis for Haskaps? Right? Usually we say, well, there's not a lot of research done on Haskaps. Well, these guys have optimum ranges for Haskaps. And I've used them in Nova Scotia. They're very accurate. They've turned out quite well in the field. And cherries are covered as well. So whether you want to do your sour cherries or your Haskaps, strawberries. Strawberries was the first crop they figured out back in '03. They got so much data on strawberries, it will make your head spin. Well grounded in strawberries. Blueberries, forage crops, canola. They got lots of targets and a multitude of crops.
So I don't want to get into their methodology, but what goes into determining the optimum range?
Oh, good question. Here's my next slide.
Holy my
I tell you, minds are linked. Great minds think alike. Alrighty, how are these optimum ranges developed? Well, it starts with a minimum of 500 plus samples, and in a lot of cases we're talking thousands upon thousands of samples. Strawberries, we're talking literally hundreds of thousands because they've been doing them for going on 15, 20 years now, right? Or 20 plus years actually. So they got lots of data. And they generate, just like every other lab, they look at those averages from all that data. But then they have developed parameters on SAP that they put through an AI computer model looking for those key parameters that indicate when they're getting into that optimum range. Now this is a bit on the proprietary side for them, but they did give me an example, for instance, is when we look at potassium, young and old leaf potassium, because again we're now looking at young and old leaf, not just one leaf, we're looking at the difference between the young leaf and the old leaf. When the difference is very small and they're almost identical with each other, you're in the optimum range. There's an example of a parameter that they're looking for. So they got these key parameters. This modeling gets them to about 80% accuracy. Then from there, field research, greenhouse research and field research to fine tune it. So they feel after they've done their field research and greenhouse research, they're getting to around a 90 to 92% accuracy, which I think from a lab perspective is pretty good. You know, that's strong enough from the ag world that we can now use this to build fertility programs on. So that's how these optimum ranges are developed. When to test? As long as you have fully functional leaves, that they're fully open and they're fully functional, we can now analyze them. See, that one of the big differences between a tissue test and a SAP test is that the target ranges don't change through the season. On a tissue test, there usually is a very specific time of year, times of the year we want to look, and those target ranges, those optimum ranges adjust. They have to, because they have to account for all that leaf dry matter. When you look at a young leaf at the beginning of the year on that Haskap, and look at it at the end of the year, does it look different to you? It's more mature. There's more leaf dry matter. There's no more waxy substance to it, right? It's a more mature leaf. So they have to account for all of that because that's being measured. And all of that has nutrient. Even though it's not available in the crop anymore, it's all in there, and it all has to be accounted for. Well, if we get rid of all that leaf dry matter and are just focusing on the sap, guess what? The optimum range doesn't change through the season. It remains relatively static for each of the different nutrients. Now, what does change through the season is how easy or hard it is for the crop to get to that optimum range. So if I'm in a window of potassium demand later in the season, I may need to put on a lot of potassium to meet that demand, to get to that optimum range. But early in the season, when I don't have a lot of potassium demand, the plant may naturally be in that optimum range just because of what it can get out of the ground. So what changes is the amount of nutrient required to actually get to that optimum range. And this is where we see varietal shifts as well. On the apple variety Honeycrisp with different rootstocks, we've seen huge shifts on this that are just groundbreaking in that industry right now, as far as how to manage potassium, calcium, and manganese, which by the way regulates K. That's a whole other story. So anyways, we can now go any time of the season and do a sap, as long as we have open, fully functional leaves. So what I suggest that we are doing on crops now is we're focusing on those major windows of opportunity to influence the crop. Coming into bloom, or in a lot of these crops, Saskatoon and Haskaps, we're coming out of bloom by the time we really have some good leaves to work with. Well, let's take a look at that point. What's my calcium levels? I'm coming into a period of new growth. I'm gonna get a lot of new leaf growth. Well, we want zinc for big leaves. What's my zinc level? What's my boron level? Is it getting toxic? This will tell us. We don't need to guess. We can actually see it, which is pretty doggone neat. I think I just kind of talked about all this. Certainly they have sampling guides for a host of crops. So if this is something that interests you, we can get you the sampling guides. We've got it down pat how to get it to Holland. You'll need to do the sampling, but Warren and I can help you get the samples to Holland. Yes, sir.
So if we have a happy plant, we're assuming we've got really good fruit, or are they doing fruit testing as well? Like, how does that work? Like, we know the plant's good, but are we just assuming that the fruit will then be good as well?
No, this is very specific on the fruit. We would then do fruit, and if we were into it, we'd do fruit analysis here more locally here in Canada somewhere, and that would also be visual. So you got to look at this with what's visually going on in the field. If I have unhealthy fruit, this could be an indication. But this is just looking at that leaf that sink called a leaf, not the fruit. So this is just one picture. But when you tie this in with a soil sample and with what you're visually seeing in the field, and depending on the crop, a fruit analysis, now we have the complete picture. But you're absolutely right, this alone is not going to give us the silver bullet. And just because it's good in the leaf doesn't mean it's good in the fruit. Like I can get boron I can get calcium really good in the leaf later in the season, but when I need it is early in the season. So there does take to be some rationalizing there to understand what you're looking at. But we're here to help you with that. Good question. Don't expect you to read that from where you're sitting, but here's what a test looks like. And what you will notice is there's a lot of lines. There's 23 different nutrient indicators. All the micros, all the secondary, all the macros, some of those non-essentials, silica I was talking about this morning, we're measuring silica. I'm going to talk about the nitrogen cycle in a minute. The dark green bar is the old leaf, the light green bar is the young leaf. We put them side by side so we can track nutrient mobility within the crop. Here's one of the reasons why I get really excited about this, is I talked about that nitrogen cycle this morning, right? Did I put it here? No, I didn't. This actually shows us the plant's nitrogen cycle. So we've got the ammonium I was talking about this morning, right? The plant takes up ammonium to build amino acids and proteins. We've got that nitrate. Plant takes it up as nitrate, converts it to ammonium before it can carry it forward. We've got the total N. That total N is a combination of all the N in the sap. Ammonium, nitrate, and then the amino acid and protein N, all the N. So now I can see how much of that total N is coming from nitrates. Because it's the nitrates that give us disease, it's the nitrates that give us insects, it's the nitrates that compromise the crop. You want your Haskaps to even more mushy? Feed them nitrates. And then don't let those nitrates cycle. You'll have a really mushy crop. Not fun. So we can now see the cycle. If we can see it, we can manage it. How do you manage it if you can't see it? We can finally see that nitrogen cycle. And what I see very, very often is ODing on nitrates. I'll see nitrogen in a crop off the charts. I had a field of hops, a 1,000-acre hop farm, approached me a couple years back. Horrendous problems with mites. And they said, Rick, can you come in and take a look and help us out? Oh, I like hops. I like beer too, by the way. Other story. Not even a chuckle. Tough crowd. Yeah, went in, did the sap work, did some soil work, did some visual inspection, said, hey, we've got a problem. Your nitrates are literally 500% higher than they need to be. Now, hops are a crop that's very photoperiod sensitive. They basically got to get the hops 30 feet or 25 feet tall in it, before the midsummer, because they stop growing upwards at that point where the daylight shifts, and that's how much, they call it a vine, not a vine, but it's a vine, and that's how much crop they're going to get. So they push the nitrates through it all spring, right up until mid-July. That's their window. They got to get to that top wire. They're so focused, they just keep pouring the nitrates. They were off the charts. Now you got to stop with the nitrates. We can't. Why not? Rick, this is what we do. You call me in because you're having problems, right? So they gave me half a block. Half a block, we cut the nitrates out. We actually followed the science. The other half of the block, they keep pumping the nitrates. At the end of the season, at the end of September, the harvest was higher where they cut the end back. The quality of the cones was substantially higher. And where they did not cut the end back, they had applied 5 miticide sprays, and the leaves were still bronzing because of the mites. They couldn't control the mites. The distance from one block to the other, 10 feet. That was it. They cut back nitrate. Substantially cut back the end, which means what? A savings in your back pocket. And they didn't have to apply 5 miticide sprays. They literally hadn't crossed the threshold for the first spray. 10 feet across. The difference was the end. So when we talk about N, nitrogen management really is our first line of defense when it comes to disease and insect pressure. And what I mean by that isn't that we need more, just the opposite. We need less. We're often putting on way too much N. Blueberries in the Fraser Valley in BC right now, we've suddenly realized they don't need 120 pounds of N per acre. Guess what? 50 to 60 is about ideal. Look how much N's coming out of your ground. 2.5 to 3% organic matter can give you 60 to 90 pounds of N per acre. Organic matter is wonderful, and it's free N in the ground for us. Organic matter from compost to manures, I'm a big fan of it. It just needs to be managed so that it's arriving at the right time so we don't create soft fruit. So pesticides, I'm not a fool, we need them. They have a role to play. But I will say, they shouldn't be the first line. They should be, I have no choice, I need that. It's getting to the point I gotta put that pesticide on. But what's your nutrition doing? That's the first line defense, and it comes down to that nitrate N. That's the big culprit, right? That nitrate N. I'm not gonna go back through this, we went through it earlier. That nitrate N not being able to convert. Well, if I can't see what that number is actually doing, how can I manage it? How do I know if my nitrate N is going off the charts? I just gave you a tool that will tell you. And then we can figure out why it's going off the charts. More often than not, it might happen to be molybdenum that's causing the problem. Maybe it's copper. Maybe it's sulfur and iron. Maybe it's a couple different things going on. But we now have the tool that when we apply it to the other tools that you already have, like a soil sample, we get a pretty complete, pretty compelling picture, which is really neat. Talked about that already, we don't need to go there. Calcium. Let's talk about calcium for a few minutes. Right time for calcium. Well, when we're talking things like cherries, when we're talking things like Haskaps or Saskatoons, the right time for calcium is during fruit cell division. Not, by the way, fruit bulking. Fruit cell division is from pedifall, lasts for about 2 to 3 weeks, maybe 4 at the most, depending on what crop you're talking. So you got about 3 weeks post pedifall, that's your fruit cell division window. That's when calcium is critical. After that, it's fruit bulking. Now we need some calcium at that time because we want calcium for the leaves. All those new shoots and everything for me, guess what? They want calcium. And if they can't get calcium from where you want it to come from, which is the roots or a spray, guess where they're going to pull it from? The fruit. So at that point, we might need to put a little bit of calcium on what I call maintenance. And that's to meet the needs of all those new leaves and shoots that are forming so that the plant doesn't pull it out of the fruit. Because in the fruit, it's giving us firmer, better quality fruit. When's another time I need calcium? This research was done, I can't remember if it was Washington or Oregon State University, did some radioisotope work with calcium. And they discovered that it's the elixir the plant moves when it gets damaged tissue. When a plant gets damaged tissue, one of the first things it does, it takes one of the most immobile nutrients within the plant and starts moving into that cellular structure to help heal it. So if I get an aphid pressure, a hail damage, or anything else that you can imagine that's damaging plant tissue, the plant's response is to move calcium into it. Now, if I'm trying to put calcium into the fruit and I want it to stay there, if I get a fairly substantial event that damages my leaves, maybe I should respond with a calcium spray as soon as I can afterwards so that the fruit calcium stays in the fruit. So there's another opportunity to apply calcium. But certainly during fruit cell division, that's your window. And by the way, that's the only window to put it into the fruit. Every other opportunity is to keep it in the fruit. But that fruit cell division, within a month of petal fall, that's your only window to put it into the fruit. So if you're going to spray calcium, that's the first time to spray it, is right in that window. Now, because of a lot of the crops we're working, that means going in right at petal fall. That's your spray opportunity. Talked about silica. The neat thing about silica in the sap test, hey, it's there. This is what started showing me what was going on with silica in the ground. Silica to come into the plant from the ground, and it's an abundance in the Earth's crust. It's one of the more abundant nutrients in the ground. But to come in, it's got to turn into an organic acid. How does that happen, by golly? It happens through digestion from the microbes. So you have soil microbes, those bugs on the ground actually feed on the mineralized silica, converting it to an organic acid that can now come into the plant. Give us that firmer fruit. And that organic acid form of silica is not going to cause the cracking and everything I was talking about this morning. It's our sprays, the mineralized silica that we put on the leaf that can do that. The organic acid silica can go off the charts through the sap, and you'll be perfectly fine. So when I look at the sap sample, by the way, and I see lots of silica, and you didn't apply any, that's going to tell me two things. First of all, that means the silica in your ground is converting to an organic acid. Well, that's microbial. So you got to have some decent soil microbial activity for that to happen. So your soil is relatively healthy because it's converting the silica over. Soils all across the planet have lots of silica. We just got to convert it. It's getting in, which means my root system must be functioning pretty decent too. So when I see high silica in a sap, that tells me that you've got a decent root structure that's functioning fairly well, and you've got a fairly decent soil health because your soil microbes are converting lots of silica. So we can learn lots of things beyond just nutrition from a sap sample, which is pretty neat. Talking about this for a minute, here's some synergies. We talked about boron and calcium this morning. I'm now going to throw in there silica. When you need silica or boron, putting it with your calcium, there's a real synergy. But I asked the question, is there a point where you have too much of a good thing? Yes. When boron and silica become toxic, they're no longer synergistic with calcium. Now with boron, we're actually killing plant tissue. We're actually killing the plant. So that's a real negative. If the silica is coming in naturally and getting high, and we want to put more silica on as a foliar spray, it may not cause cracked fruit, but we do lose that antagonism with the calcium. So we really got to be careful. If we already have high silica in the sap anyways, in the plant, in the sap, in the leaf, why would we apply more anyways, I guess I would ask myself. Boron, so post-harvest. Now, on cherries and all these crops that are well into bloom before we have a lot of leaf structure to work with, blueberries are another one. You can think of a couple crops, right? Stone fruits are a really big one for this. We often used to apply boron in the spring. Boron is required for pollen and pollen viability and flower health. You heard me say that this morning. But what we're finding on these stone fruit crops and other crops that flower or are well into flower before they leaf out, putting it on when they leaf out, we've missed the bus. We've missed that window because it takes some time for the plant to absorb, metabolize, and utilize that boron. What we see now, we've seen it with the sap, is when we're putting boron on at bloom, we've missed the window. The boron doesn't come up when we need it to, but it spikes later. We've created a boron toxicity, which we now know we don't want, later in the season. So on these crops, if I need boron, because my soil tells me I'm low on boron, I have less than 1 ppm, I'm 0.8 or 0.5 ppm in my soil test, I need to put boron on. When do you put the bulk of your boron on? In the fall, post-harvest, past Labor Day. That's your window for putting boron on. You got to get it in then because you don't have, on a cherry, you don't have that opportunity in the spring. You can put a little smidge in with your calcium in the spring, And we have some products. If you look at our program, I've got a Calbor Molly. It's got 0.6 boron in it. It just helps with that calcium uptake in the spring. That's perfectly fine. But you don't take a 9 or 10% boron product and fully apply it in the springtime on these crops that we're talking about today. You'll push the levels too high, and it will be post-opportunity, and you're going to create problems that are going to set you back. So boron has to go on in the fall. That's when you put the big rate on. Zinc. If I need zinc, putting it on post-harvest is going to help me over winter. You happen to get some winters around here. How well you overwinter kind of matters. Think of zinc a little bit like antifreeze. If I need zinc, zinc is going to give me some antifreeze. So your post-harvest spray in this neck of the world is pretty doggone important for bud health. Now, Haskaps are pretty doggone hard to kill. I mean, we all know that, right? I mean, I remember I was working with a Haskap farmer out in Nova Scotia, 45 acres, and he had a bunch of Haskap, 45 acres, pretty decent Haskap farm, eh? I was impressed. He blew my mind away. Wow. Anyway, I had a bunch of leftover Haskap plants. Piled them up in a pile in the corner. 2 years later, they were rooted and growing. It's like they were discarded plants piled into a corner in Nova Scotia. 2 years later, they were growing. Just amazing plant. But I don't want a plant. I don't get paid for the plant. I get paid for the fruit. Fruit damage, zinc, if I need it, and the sap will tell us, and the soil test will tell us, if I need it, zinc will help those buds over winter, particularly those fruiting buds, so I actually have fruit to harvest next year. Potassium will help the plants harden off for winter. Another trick that I will mention today, if you got plants, say because we have these winters, these falls that have gone weird, where we get warm, and then all of a sudden we get cold, right? And I want to encourage those plants to shut down before it gets cold. 2 years ago, we had plants in the Okanagan. We didn't have a frost to January 10th. Our first frost is usually in September. It was wild. Well, we want those plants to shut down. Here's a trick for you. Anybody here use copper spray? Copper fungicides? You know, copper oxychloride, copper hydroxide, those type of sprays? You go to, not the newer ones like Cueva, they're too gentle. You go to one of the old products like copper spray, as long as it's on the label, you know, label's the law, but as long as the crop's on the label, you go with the copper spray twice, back to back, 5 days apart, you're going to shut that plant down. There's a little trick for if you want to encourage those plants to shut down and drop their leaves. You're getting close, you're getting some cooler nighttime temperatures, but they're just not shutting down as fast as you want them to. 2 back-to-back, 5-day interval, copper fungicidal sprays, doing 2 things. You're cleaning them up, forcing lignin formation, and you're going to shut that plant down. It's going to start dropping leaves. There's a little trick for you. Phosphorus into the season, great, and of course early in the new season, phosphorus and nitrogen to get you going. Talk about this already. Remember though, foliar nutrition, and I do got some foliar programs for you to pick up on the side. You know, I'm making a big part of my living selling foliar nutrition, so take note with what I'm about to say, please, pretty please. Foliar nutrition is to augment the fertility program, not drive the fertility program. Your base fertility on any crop you grow has to come through the root system, has to come through the soil. It's the biggest highway to move nutrients into the plant. You cannot move enough nutrition through the plant from a foliar perspective. I don't think there's anybody here that's expected to do just a foliar program, but I do periodically run into farmers and say, I'm going to do everything foliar this year. I said, great, your crop's going to be a train wreck within a year or 2. Because you can't. You can't. That highway, that road is not wide enough to move in the nutrition you need to. Foliar is meant to take advantage of windows of opportunity to improve yield, to improve fruit set, to improve firmness, but it's not to drive the bus itself. Tank mixing. So when you're tank mixing, one of the key things I want you to take away from this is when you're putting different things in the spray tank, dilution is the solution. And what I mean by that is dilution's our friend. I can get away with putting things in the spray tank together if there's lots of water present. That won't work if there's not enough water present. A good example is when you put a phosphorus product and a calcium product in the same spray tank, they will react, and I've done it by mistake, and it's what we call an exothermic reaction. The tank gets really hot, so you're going to fry pumps, by the way. I've done it. Not much after 35 years that I haven't done, but that's one of them. I've fried pumps. But if I have lots of water in the spray tank before I put the second one in, I got lots of dilution, guess what? No issue. But when you put them together when the tank's only 1/3 full, they're going to react and you're not going to be happy with me. But you put them together when the tank's already full, you're not going to have an issue. So dilution is our friend. Do not cut back on your water volumes. Yes, it means less trips, but it also impacts coverage. When mixing, always start with a clean spray tank, right? It's hard to do in the middle of the growing season, I know that. Always start with a clean spray tank. To that end, I want to talk for a few seconds about a product that we have that might help with that. And it's called Oro Solute. Oro Solute is a utility modifier for the spray tank. It actually helps things work better that are mixed in the spray tank. But one of the added benefits of this product called Oro Solute is it has alcohol solvents that pull things into solution. So everything in the spray tank, so I've got all these different compounds in the spray tank, and they get sometimes a bit thick, right? Kind of hard to spray. This is going to help prevent nozzle clogging. It's going to pull everything into solution, keep the spray tank cleaner. Matter of fact, I had an apple grower that ran a tank of this not that long ago in Nova Scotia, and his sprayer wasn't overly clean when he started it, but when he was done that spray tank, he said, Rick, I couldn't have pressure washed the screens cleaner. So it's keeping the screens cleaner, it's keeping the sensors cleaner, it's keeping the nozzles cleaner, so much so that what we tell people when you're putting this product on for the first time, make sure you run it through as a cleaner with some cleaning agent, because it will pull pesticides out of the polymer in the side of the spray tank. And that could be a problem if you got the wrong thing in the polymer, right? So the first time you want to clean the tank using this product, because it's going to pull things out of the polymers. That could cause a problem. Now this Oro Solute has a technology in it called Oro Wet. Orange oil, cold pressed citrus oil. Has some interesting parts to it. The cold pressed citrus oil, when you put it on at the right rate, it kind of creates a molecule collection, conglomerate in the spray tank around the pesticide in the spray tank. We call this a mycel. So think of a molecule cluster around the pesticide. Kind of some neat benefits to it. Here's what it's doing. The Oro Solute, again, that molecule cluster mycel around the pesticide, when we get to, and this is all by percent volume per volume in the spray tank. So when we get to that 0.125 to 0.15% volume per volume in the spray tank, we're now getting this mycel formulation good enough that it's going to carry the pesticide. We're getting increased systemic activity of those systemic pesticides. So that orange oil at this rate is helping keeping everything in this, the lower volume rates are helping keeping everything in solution in the spray tank, helping keeping this tank cleaner. Great tank cleaner. Like I said, screens couldn't be cleaner. You couldn't pressure wash them cleaner. But it's also helping spread it over the leaf so we get good penetration, good coverage. If I'm going after a cap 10, and by the way, never mix cap 10 with fertilizers. Just a side note. Cap 10 and fertilizers, going to be a problem. And solupaks and boron don't get along well either. You want to make sure they're fully dissolved before you put your boron in the tank if you're doing a boron product. But at those lower rates, so under 0.125% volume per volume, I'm getting good leaf coverage, which is important for a contact. But at those higher rates, I'm getting that mycel formation in the spray tank that is now helping with transflow mobility of that pesticide. This is actually taking Roundup, you're getting killed twice as fast. So if you've got tough weeds that are hard to control, on the prairies out here, and you can talk to Warren who knows this better than I do, kochia is kind of the problem, isn't it?
Yep.
Glufosinate, kind of the pesticide we're tending to go to. Mm-hmm. This will actually allow glufosinate to control kochia, which is pretty doggone neat. So, interesting product for you to think about. It is actually improving how pesticides are working in the spray tank.
Change the pHI at all if you're spraying a contact and now it's giving you the plant a little more?
No. Am I correct on that, Warren?
Sorry, I didn't hear that, sorry.
Pre-harvest interval.
Pre-harvest intervals. It's not changing the pre-harvest interval.
Still not active.
Yeah.
You're not changing that.
No.
It's just be more.
Good question. And it's more effective, and you're also not making it hotter. You're making it more efficient because you're moving into the plant better, but you're not making it hotter, which is also a question I often hear. Pretty neat product. So, now talking about when we do spray, don't spray in the heat of the day. Do you know that 27 degrees on a sunny day, straight water in the tank is going to fry your leaves? gonna burn them, gonna leave little spots on them. You know, you wanna spray on dry leaves, not wet leaves if possible. Morning dew, kind of wait if you can. I realize that some of these are not as easy to do. Don't overspray. If you're spraying a contact, you know, nice damp leaves, we don't want them overly dripping. You know, more is not always better, right? That's kind of one of my messages of the day. More is not always better. Oh, I didn't have it, so I'm gonna say it anyways. I thought I had a slide in there. I got what I'm calling, in respect for my colleague who's passed away, Del Christensen, is the Del 150 rule. When do I spray and when do I stop spraying? Well, Del's 150 rule goes this way. Now, he's American, so it's Fahrenheit, not Celsius. But Del's 150 rule is this. Take your temperature in Fahrenheit, and add it to your humidity, your percent humidity. The closer you get to 150, those leaves are shutting down. If I'm putting on a fertilizer, a foliar nutrient spray, do I need it on the leaf or in the leaf? I need it in. I need systemic activity. If I'm putting on a systemic pesticide, it needs to get in too, doesn't it? Whether it's a herbicide or a fungicide, an insecticide, it needs to get in. So if I'm at 140 or 145, when I add those two numbers together, don't spray fertilizers or systemics. Go to the contact if you have a problem. Because they won't work. The leaf is shutting down. If the leaf is shutting down, there's no transpiration, respiration, there's no movement and systemic activity. So there's what Del's 150 rule. The closer you are to 150, the less likely you should to do a systemic spray of any sort, nutrient or pesticide. Like I said, I have some programs over on the sidewall if you're interested that kind of give you some ideas. You'll see things like the Biomax for soil stimulation once the soils start to warm up to work with the biology. You'll see my calcium in the early window around fruit cell division. You'll see phosphorus coming in right near the end of cell division to help drive more, or sorry, right near the end of petal fall to drive that cell division to get better quality fruit. You'll see K later to help with coloring. You know, Saskatoon's gonna be a heck to color, right? Well, K can help with that potentially. Good, I'm just about done. I'm on time today, this afternoon. So you'll see the timing of the different products. Now, do you need all of them? Likely not, but it gives you a good idea, and the SAP can help guide you to what you do need to tailor it to your place and what works for you. There's a program, so that was cherries, there's the Saskatoons. You notice they're a little bit more condensed. We don't need as much of the Saskatoons. Cherries can be a little bit more of an intensive crop. Gets even less intensive with Haskaps. As I said earlier, it's pretty hard to kill Haskaps. They're pretty resilient in many, many ways. But we need them to produce a fruit. And we need that fruit to be firm enough that we can get it off and that we have something to work with. One last slide here, because I know you might get a little bit of frost from time to time. We have a potassium simple sugar. It goes under two names. This one's with KDL. The sister product to it is called Potassium Finishing Solution. We have had great success with this product on a multitude of fruiting crops, from apples and pears to grapes and berries, from blueberries to Haskaps in the east, for frost protection. And what we're doing with this product is it's a simple sugar potassium. It's shifting the K to nitrogen ratio in favor of K, so we're slightly hardening off the crop for a short period of time, and we're putting in a sugar base. Sugar freezes at a lower temperature than straight water, and we're finding we're getting around 3 to 4, sometimes even 5 degrees worth of frost protection. It is not a silver bullet, but it does make a difference. So we can get up to 3 to 5 degrees of frost protection. It does need to be on 12 to 36 hours before the event takes place, so that it can be metabolized and in the plant before the frost event happens. Obviously, closer to 36 hours is better than the 12, but there's your window, 12 to 36 hours. And if you do get a frost event, and you think you've got some tissue damage, what should you do next? Tissue damage, we want to heal that tissue damage. Calcium. That tells me I've done my job today, thank you. Any last questions before I go down?
So does the frost protection or like ADL work well for strawberries?
Yes, yes. I remember when I was first getting familiar with this application in a room much like this with Dell in Nova Scotia, and we just asked a bunch of strawberry growers out there that are your propagators,
Yeah.
right? The Millens and Kettys of the world.
Yeah.
Hey, KDL and frost protection. And I just sat down, it was amazing how they have all experienced it, and yes, absolutely does. Yep. Yes, sir.
You have a very thorough stone fruit program. Now, if I was not compelled to all these products or whatever.
Absolutely.
If
That's
you
the
went
kitchen
with,
sink.
yeah, if you went with a calcium product and a micronutrient package and you did a 2 glug approach every time you did
Yep.
an application,
Yep.
is that a poor use of nutrition?
Absolutely.
Poor use or good use?
Poor use.
Poor use.
Here's what I would do.
Okay.
If I had to focus on two things, I want to do my calcium, and I don't want to do that really all season. I really want to focus it, particularly if I got to choose when I'm putting it on, fruit cell division window. So right at petal fall, right? That's my calcium timing. So I'm going to put my calcium there, and then we get after we're done with petal fall, we get a flush of new growth. That's when I put the rest of my micronutrients on. Maybe once or twice at most. There you go. Peer program, 3 or 4 applications at most. Putting on the micros, and what I'm doing with the micros, particularly with a product like our Zinc Plus 5, I'm driving leaf development, vascular tissue, and leaf function, which is all the sugars that are going to make me color later, right? The calcium is going to give me better fruit. So calcium early, and then a couple micronutrient applications. That is what I would consider a fundamental base. But I wouldn't put them on through the season. I don't need that calcium all year long. It would be nice if I get a lot of growth that I'd maybe put a late season calcium on, but the real focus needs to be, and the real money needs to be spent right after petal fall. And then the micros, during fruit cell division, I don't need a lot of those micros because the plant is focused on fruit cell division. When I need it is after that cell division is over. Now I'm worried about leaf development and leaf function. Now it matters. So putting them on just through the season, I'd rather focus them a little bit to those windows of opportunity, if I'm making sense.
Okay.
Okay, good question.
If the, just with the foliar, spraying foliar on,
Yep.
that's absorbed through the stomata, correct?
And the membrane, but primarily for the stomata, yes.
Is that, like for strawberries, isn't that mostly on the underside of the leaf?
Yes, but that's why I said primarily through the stomata. You're getting both. But yes, when you're spraying a leaf, I want both sides wet.
Okay, so
Yeah.
how do you apply that?
A little bit of a higher pressure, fine mist. But yeah, you want the leaves moving. You want both sides covered.
Okay.
Absolutely. It's not a gentle spray. I'll caution though, it's also not an aggressive, it takes less pressure than you think to move those leaves around. Like if I'm in a field of Haskaps and you're spraying here and I'm 50 or 40 feet away and I'm getting mist, your pressure's too high. I should be able to stand a few rows over, not that I'm going to from a health and safety perspective, but I should be a few rows over and not feeling the mist from the sprayer. So we want the leaves moving around so we get coverage top and bottom, because we want to maximize membrane absorption on the top and stomata absorption on the bottom. But not so much that we're spraying it throughout the air. Air doesn't give us fruit.
So if it's like a little windy, maybe does that help a little bit? The leaves are...
It does a little bit of wind, but again, there's a level there, right? It gets too windy, I'm losing. So a little bit of wind, maybe not bad. It's amazing how much we'll have to push the window sometimes. That's farming, I get it. But it's amazing how little pressure it takes to get that leaf moving when I'm spraying it. I've stood there watching with water with calibrating sprayers and stuff. And it's amazing how little the pressure is to get that. But you're right, you want both sides covered, not just the top. You don't want to be so gentle with them that just the top is being covered. Yep. Any other questions? Those were amazing questions. Thank you for your time. And thank you for putting up with me twice today. You came back after lunch and you stayed awake. Thank you very much. I appreciate it and have a great afternoon.
Thank
Thank
you.
you.
Thank you.
Thank you very much for making the trip all the way up
Thank
here.
you, Angie. Appreciate it. You bet.
Great. Okay, we have one last session. It is, Carson's gonna come talk to us from Southern Irrigation. So we'll get him set up.